Alright folks, today we're working on correcting mock EOC questions number 11 and 12. Number 11, what is the x-intercepts of the ellipse with the equation 9x squared plus 4y squared equals 36? So, hard word here is this ellipse thing. We have a formula sheet that you can look at, and when you look at it, it doesn't tell you anything about the intercepts. So, I was thinking, we actually know what intercepts means. If we have an x-axis and a y-axis and x-axis, it's asking for the x-intercepts, which says that somewhere along this line, and maybe at multiple points, maybe at one point, we're going to have, wherever this shape is, whatever this ellipse shape looks like, it's going to cross the x-axis. That's what it means by x-intercepts. It says where it's going to cross the x-axis. There's one thing in common everywhere along the x-axis. This might be 1, 0. This might be like 4, 0. This might be, I don't know, 10,000, 0. This might be negative 1, 0. The thing that all these points along the x-axis have in common is that everywhere y is equal to 0. So I'm just going to copy this equation down. 9x squared plus 4y squared equals 36. And I'm going to change y to equal 0. So we don't know what x is. We know y is equal to 0, which is going to make our life easier because now we have one equation, or one variable equation. We can just solve this. So 0 squared is 0 times 4 is 0, so we get 9x squared plus 0 equals 36, which is really just 9x squared equals 36. Divide both sides by 9. We're going to get x squared equals 4. Square root of both sides, square root of x squared is x. Square root of 4 is both positive and negative 2. Positive 2 times positive 2 equals 4, and negative 2 times negative 2 equals 4. So we have two solutions, which, as we're looking at, answer A. Oh wait, number 2, or number 12, and this is, let's cut off all this stuff. Write 9 minus I squared divided by 3 minus I in standard form. So whenever we have I, there's a couple things we have to remember. Number 1, I squared equals negative 1. So anywhere we see I squared, we can place it with negative 1. And part 2 is that standard form is A plus BI, or A minus BI, but basically, we've got to get rid of this denominator. So, the first thing I'm going to do is just copy this down. Actually, I squared is equal to negative 1, so I'm just going to replace this with negative 1 first before I do anything else. So I get 9 minus negative 1, which is 10, divided by 3 minus I. Didn't do anything with that bottom part, the denominator. So we need to multiply by the complex conjugate is what it's called, which basically says, and we actually saw this on one of our previous problems. I think it was yesterday, on problem number 9. So number 9 talks about complex conjugate. Anyways, we just switch the sign of the denominator. So we're multiplied by the same thing, except we switch the sign, 3 plus I. We switch the sign in the middle. So we're going to multiply. We've got two terms here. So 10 times 3 is 30. 10 times I is 10I, all divided by. 3 times 3 is 9. 3 times I is plus 3I. Negative I times 3 is minus 3I. And negative I times positive I is negative I squared. So we've got some simplifying to do. It looks like in the denominator. Positive 3I and minus 3I will cancel. We're left with, let's see, 30 plus 10I, all divided by 9 minus I squared. Again, we need this fact that I squared equals negative 1. So 30 plus 10I divided by 9 minus negative 1, which is going to give us 30 plus 10I, all divided by 9 minus negative 1 is 10. So this is two different fractions. This is 30 over 10 plus 10I over 10. That's our separate fraction. We just keep whatever sign's in the middle. That just pops in here. And we have to simplify each of these. So 30 divided by 10 is 3. 10 divided by 10 cancels. We're left with just I, which says we have answer B. All right, folks, make sure you pile these in the center of the table when you are done.